Hello, I'm gonna solve the number 22 to generate parentheses. Okay, let me read the problems. Given n pairs have parentheses, write a function to generate all combinations of well-formed parentheses. For example, given n equals 3, a solution set is as follows. As you can see, there are 6 combinations of well-formed parentheses. So at first I tried to solve this problem using the brute force way with the recursive function to generate all the possible combinations of open and close parentheses. Okay, let's see the code. As you can see in the code, there's a recursive function. There is a recursive function with open parentheses and close parentheses, and increase the count variable for open and close parentheses respectively. So the open count and close count are compared to exit this recursive function after pushing back a current built-up parentheses combination. Before doing it, we have to check the current built-up parentheses combination is valid or not. Valid function is simply simulating the stack operation using top variable initialized by 0. For loop, iterate the parentheses string from 0 to the end. If it encounters the open parentheses, top variable is increased by 1. In else case, top variable is decreased by 1. If the top minus 1 is under 0, we can know it's not valid, so we have to return false. Unless we have to check the top variable being 0, which is valid parentheses, so return true, or we should return false. So with this solution, I got 8 millisecond runtime, which is faster than 54.24%. It's not so fast because I used the brute force way. And then just before recording this video, I realized that there is some improving point in my code. Okay, let's get back to the code. I'm using this condition, the close count should be less than the open count, to call the recur function with close parentheses. This condition already verifies the valid parentheses, so I don't need the validation check before pushing back the result. So by removing its valid function, I got 4 milliseconds runtime, which is faster than 88.29%. But when I was searching the other people's solution implemented in C++, there was a 0 millisecond solution. So I was curious, what's the difference from my solution using the recursive function and the backtracking algorithm? Okay, let's see the 0 millisecond solution now. Okay, let's read the brief explanation. First, I compute the Catalan numbers so that later on I will know how much memory I will need, then I allocate the memory for each vector of correctly matched parentheses of length I, where I iterators from 0 till n. And addition, unnecessary memory will not be twice more than the memory needed to return the final answer. In his code, he used the also problems table, which is a two-dimensional vector string, and he called it the Catalan number function, which returns the cat nums array calculated by the Catalan number algorithm. I think that this calculation is not very important in this solution because this is to predict the necessary memory for also problems table to allocate in advance for better performance. Most tricky part is for loops to build up also problems table and finally return the last element of the table. To understand this code, we have to understand what's the table containing. To understand the also problems table, I added the debugging code, printing out the table information like this, and I could trace how is also problems table are changing and finally get the result. So I'm going to explain how to build this table to get the result in a more faster way. Also problems is a two-dimensional vector array storing parentheses. This particular number is the index of all subproblems. In this code, four for loops are used with index I and j. and the element 2. Element represents a parenthesis string like this. This table is basically a dynamic programming table. To get the next result, it uses the previous solved problems, building up table from 0 to the n. That's the reason this code is more faster than the brute force and the backtracking solution. We have to focus on how these indexes are moving and pushing the new parentheses combination. New open and close parentheses are added surrounding element variable, and element 2 is added on the right side. So let's see how to create or build up also problem 3 elements from the previous index 0, 1, 2 elements. Actually, in the for loop, the element moves from 2 to 0, and the element 2 moves from 0 to 2 in reverse way. This is for always creating 3 pairs parentheses string. So in the first iteration, the element has the parentheses like this, and the element 2 has the non-string. This is also a single element. So the push statement in the for loop creates a 3 pair parentheses with the element and element 2 combined by new surrounding parentheses. In second iteration, EL and EL2 have the same parentheses element, so another single 3 pair parentheses is created. In last loop, element has an empty string. Element 2 have 2 vector items like this. This is the vice versa of the first loop iteration, but it creates a different parentheses combination because element 2 is located in the right side. In this way, we can create the next index elements using the subproblem data built up so far, getting the final result much faster than other brute force algorithm. Okay, thank you for watching. See you next time. Bye bye.